Anyways, here we go. We are doing, chapter 11, we are doing area and volume. By area, I mean surface area.
Ooh, fun.
But today, specifically, we are actually going to talk about Euler's formula.
Who?
Now, we aren't going to derive it or kind of think about like where it comes from. We're just going to use it. So Euler, however you want to say that. I'll say it Euler. Anyway, here is his formula. F plus V equals E plus 2. Okay, well, what is F? The number of faces. What is V? The number of vertices. What is E? The number of edges. Well, what am I talking about? I'm talking about a prism. So let's verify Euler's formula with a cube. So here is a rough sketch of a cube. So you're going to want to get used to drawing in 3 dimensions. And we'll actually talk about that today, since this formula is not that difficult to get down. It's like one thing for today, so that gives us some time to talk about, well, how do you even draw all these pictures? Because you're going to want to be able to see in dimensions in order to do surface area and volume. So we're going to use dotted lines to represent sides that are hidden. So let's verify this formula. How many faces do I have on this cube?
6.
6. So F is 6. All right, now how many vertices do I have? Well, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 vertices. Well, how many edges do I have? Well, let's go through each of the edges and I'll draw them in yellow so it doesn't show up too bad. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 edges. So we have 12 edges. How do I know? I counted them. All right, so let's verify the formula. F plus V must equal edges plus 2. So 6 plus 8 must equal 12 plus 2. 14 equals 14. Yay. Okay, so we have verified that formula. Now, let's say that I'm missing one of these. Like I know 2 of the things, but I want to know the other one. Well, then it's just an equation. So let's set up an equation. Any questions on how I verified the formula? Yes?
How do you draw that shape?
Okay, we'll get to the 3-dimensional drawing in a moment.
Okay.
Let's do the next shape. Let's say I have a pyramid. We'll have a square pyramid.
No.
So we're going to have a square pyramid, and I'm going to tell you that I know that I have 5 faces on the square pyramid, and I'm going to tell you that we have 5 vertices on my square pyramid. And I want to know, well, how many edges? Now, you could, of course, draw this and figure it out that way. But maybe we don't want to draw because we're not good at it. So we'll use Euler's formula. Faces plus vertices equals edges plus 2. So we have 5 faces plus 5 vertices must equal the number of edges plus 2. So we have 10 equals edges plus 2. Subtract the 2. 8 is the number of edges that we should have.
This is going back to pre-algebra.
So, pretty simple. Yeah, using Euler's formula should be pretty simpler. But let's verify that with a drawing. So, here's our pyramid. Now remember, we're using dotted lines to mean hidden sides. So I have a couple hidden sides right here, right?
Yeah. No, yeah, yes, sir.
Okay. So let's count. Well, there's my 5 vertices. 1, 2, 3, 4, 5. And I have, let's count we were looking for the number of edges, right? So let's count. 1, 2, 3, 4, 5, 6, 7, 8. 8 edges, verified by a diagram. Now, we do have a special, we have to go through some definitions here. Any questions on using the formula?
No.
No? Okay. Then we will go on if there are no questions. Definition of polyhedron.
Polyhedron? Are they related to the
Okay.
Sanhedrin?
Okay, well, no. Okay, stop with that extra. All right, well, let's remember what a polygon is. A polygon is a two-dimensional shape. Okay? Such as this. That's a polygon. This is a polygon. This is a polygon. Those are all polygons. They have many sides, right? When I'm talking about a polyhedron, first of all, it's a three-dimensional shape. It has many sides, that's true, but we would say it's made of many polygons. But these polygons are going to have a special property that makes these a polyhedron. A polyhedron is made of many polygons that are regular. Well, what does regular mean? They all have the same side length. Okay, the same side length. So I'm not going to be able to draw this because this is one thing I'm not really good at drawing, but I'll make a noble attempt. So say I start with a pentagon. Well, a polyhedron is then going to have another pentagon attached to each of these sides. So then I would have a pentagon here, and I'd have a pentagon here, and you can see that I really have flubbed this up. A pentagon here, okay, a pentagon here.
Can't you just draw
1,
squares?
2, 3. Yes, I would have a cube. Okay, we have already done a polyhedron. I'm showing you a polyhedron that is not squares, because we already did a cube, yes? Anyways, this would wrap around. Okay, I'll show you on a software how that does. Okay, now not every polygon is going to have a polyhedron with it. For example, I can't do it with octagons. I cannot have, it's impossible to have an octagonal polyhedron because, well, the octagons won't line up. So if I try to draw octagon, if I attach an octagon right here, let's go ahead and try that. Try an octagon right here. Okay, I can't attach it right here. I'd have a square. I'd have squares inside all of these corners. So that would not be a polyhedron. I mean, I could make it. So your book actually gives you a pretty good picture of a polyhedron, but we're actually going to use Euler's formula with some of these. So let's try it. Let's say I have a polyhedron that has let's say it has 30 edges and 20 vertices. Well, then I want to know, well, how many faces does this thing have? Well, I'm going to use Euler's formula. So F plus V equals edges plus 2. Now listen to me. This is going to be very important. This is so easy, I'm not going to review it. You need to remember it after today. Okay? So this formula pops up on your first quiz, and we probably won't talk much about it after today. So edges is 30, so I'm just going to do a replacement here, right? And F, I'm looking for F. Vertices is 20. So I get 32, 20, and F. I'll subtract the 20, and I get 12 faces. Okay, I want you to try one. I'm going to give you that the number of faces is 20. And I'm going to give you the number of vertices is 12. I want you to tell me, well, how many edges are there? go ahead and figure that out. Okay, what do we get?
30.
Okay, good.
Any questions on how to get 30 for the number of edges?
Nope.
Anyone need to see it? Going once, twice,
So,
so. Alright, cross sections. You are definitely going to want to be able to think in cross sections for this unit. So let's say, oh, I thought that was going to be a cylinder. It is not the cylinder. So I'm going to have to draw a cylinder.
fun. It takes time out of class.
Okay, try to draw this wonderful, beautiful cylinder.
Looks great, Mr. K.
Okay, so there's the cylinder. Now suppose we can be quiet. When I do a cross section, what I'm going to do is I'm going to pass a plane through the shape, and I'm going to pretend like there's ink all over this, like it's filled with some sort of ink, and somehow when I pass the plane on it, the ink doesn't spill out. And when I do the cross section, I'm going to ask, well, what shape would be left on that paper? Okay, so I'm picturing this cylinder here. Suppose I pass a piece of paper through the cylinder horizontally like this. Well, what shape then, if I cut right through this, and it didn't smear or anything, if I cut through it, what shape would be on this piece of paper? Well, hopefully you say a circle, right?
Yes.
Yes, we say a circle. Okay, now, suppose I do it vertically.
Rectangle.
Okay, and I pass it through vertically. What shape? Someone said it. It is a rectangle. I would get a rectangle. See, this would cut through. And I'd get a rectangle. Does everyone see that that would be a rectangle? Now, as I move this plane to the right, what would happen to my rectangle?
Bit smaller.
In which dimension? Would its height get smaller?
No.
The top and bottom, so we would say the width of my rectangle would get smaller as I go further from the center, right?
So it would like curve?
It wouldn't
No, the width
curve,
would get smaller.
the width. So we go
Oh,
from
like that.
being very big,
okay.
like
I get
this. Its height would stay the same though. And then eventually, what if I got right to the very end? What would I get on my cross section right at this end?
A
right
line.
here? A line. Good. That's cross section. Let's do one more cross section.
Is there a spare tennis ball?
Okay, don't worry about that.
That's bugging.
Let's say I have a pyramid.
Trigger.
Sure.
Now I'm not going to draw the, well, sure, I will. Why not?
I'm not gonna go. Okay.
Okay, we'll say that this is a square pyramid. Okay, so here's my square pyramid, and I'm going to do a cross section through it. So let's say I do a cross section horizontally. So I pass my paper through it horizontally like that. What shape do I get on my paper?
A square.
A square.
A square. So I'll get a square is my cross section if I go horizontally. Alright, what if I go vertically?
A triangle.
I would get a... do I get a triangle?
Yeah.
Let's think about that.
Where it's at.
Yes, it does depend on where it's at. So the square, now as I come up to the top, when I go horizontally, it comes up to a point, and then as I go down, it just gets bigger and bigger as a square.
Right.
But let's say I'm going vertically. Right, here's my plane. I'm passing it through. Suppose I pass it through right there. What do I get?
Trapezoid.
A trapezoid. So when I go horizontally, I could get a point and then as I go through, it'll become a bigger and bigger square. But as I go vertically, okay, I'm going to have a line. It's going to be a trapezoid. But it does eventually become a triangle, right? In the center, what do I get?
Triangle.
A triangle. So in the center, vertically, I'm going to get a triangle.
Yeah, how did you get a trapezoid? That's good idea.
Okay? Watch.
I think we need like normal shapes that we can look at.
Okay? Watch. You see it?
But if you keep going in where that
But if I keep on going in, I'm going to get a triangle. Right here, I would get a triangle. So the top, what's going to happen is the top of this is going to get increasingly small, and the bottom of this is just going to stay the same. Okay? So it does depend upon where our cross section is, what we would get. Okay, really quick, we'll do drawing in perspective. Now, if you've had art, you should have already done this, but I will talk about it quickly. So you can do it. For now, I'm going to show you one vanishing point, and then later in the chapter, we'll do 2 vanishing points. So this is drawing in perspective, 1 vanishing point. Typically, your book uses 2 or 3. 3 is really tricky, but 1 vanishing point, not that hard. So what we're going to do is we are going to choose a vanishing point. There's my vanishing point. Okay, so all my lines are going to have to somehow draw toward that. So let's say I want to draw a cube. I'm going to start with a square. There's my square. Now, I'm going to imagine that all these edges from the vertices go toward that vanishing point. You see how I'm imagining?
It was like art.
Okay, now, that's what I just said, right?
Oh.
Okay, so then I might darken this, bring it up, go across, and hopefully you see how I did that. And then all these dotted parts back here, like so. Let's say I did a pyramid. Okay, now a pyramid, I'm not going to want to start with a square, right? I'm going to want to start with, now it depends on my base, right? So let's say I'm doing a square pyramid. Okay, so there's the bottom, and I'm going to imagine, okay, I'm going to imagine these lines, right? And I might say, all right, well, here is, oops, I wanted that to be green. Here's the other edge. Here's the other edge. Going here. Now I need a top of my pyramid. This is where it's going to get pretty tricky. Maybe I'll put my top of my pyramid right there. So I'm going to imagine this is going to have to connect there. Connect, connect, connect. There is my square pyramid. Now, spheres and things, I'm not necessarily going to use a vanishing point. If I wanted a sphere, I'm going to draw a circle. And I'm just going to imagine a ball. And I get a pretty good idea that I mean a sphere right there. All right, that's it. Put away your notes.